That right there probably tells you all you need to know about this channel. Hello again, my internet friends. Always great to see you. Oh, it's been a while, hasn't it? Well, unless you're working through a playlist, in which case, great to see you back again so soon. Pull up a chair. This isn't the video I planned for. I had a different video planned for today, but that'll have to wait until tomorrow because I got sidetracked. Quick backstory, not long ago, a little after that last video actually, I managed to cut the palm of my hand open like a banana. Not here in the shop, mind you. I was actually out in the garden. Don't know exactly how it happened. I was cutting towards myself just like they tell you to, and bam. Next thing I know, I was in the car heading to the ER. Thankfully, that seems to be healing up well. Doesn't look so bad now. But for how deep it went, I sure wasn't bleeding very much. Doc told me it must have been a very sharp knife. I was like, dang straight it was. I was borderline offended. Had they not watched my Tormek video, needless to say, things slowed down around the house, and I whiled my time away tending to a half dozen way too tight stitches, if you ask me. Trying my best not to tear those open. And I decided it'd be a good time to catch up on some reading maybe. Exercise the old brain. Get some intellectual nourishment. So I spent a few days on the couch doom scrolling YouTube shorts. When out of nowhere, I tell you, this came across my feed. It was a video of someone like power burnishing their lathe work. It looked too good to be true. And, as they say, the rest is history. Or it will be once I try this for myself. Hold on a minute. Maybe I'm getting ahead of myself and this isn't as self-explanatory as I think it is. Let's back up for just 1 second. In this video here, our friend is using a ball, like a hardened metal sphere like this one, to burnish their lathe work, and they're turning out a frankly spectacular and a little hard to believe surface finish. I like to think I have my finger on the pulse of 60s, 70s, and 80s hobby machining, but I've never seen anything like this before. I mean, sanding, lapping, sure, but I've never seen power burnishing. It's like bizarro world knurling. A tool that holds a ball as it smashes down all the high spots. Power burnishing. Those are two words that shouldn't be put together. I mean, it's like chocolate and peanut butter. Can you even fathom those two things coming together? I'm just digging around for parts that look like they might be about the right size. That's probably good, but a little too, wide. One of these two might do it. And I don't have as big a selection of metal spheres as I thought I did. Those are the same, that looks too small. I guess this one should do. Again, I'm just spitballing here. I like that this one's wider. Anyway, I think we need a ball and a bearing, like a ball bearing, to take those burnishing loads and to keep that sphere turning. Support it from the back, keep it free spinning. And then we'll need to pick some size material that fits in the tool post and looks like it could hold these parts. But full disclosure, I'm not super shocked that this might work. I mean, it seems to make sense, right? What I'm curious about are the forces involved. Like, am I about to send the cross slide of my lathe on a one-way suicide mission? Or is maybe just that local contact point, that single contact point, enough to get the pressures really high? And if that works, what happens dimensionally? Like to the part, how much will the diameter change? I suppose that depends on how rough the last cut is, how big the ridges are I'm leaving behind and I'm smushing down, and how much pressure I'm applying. I guess we'll see. Well, now comes the one and only hard part about this build. Or it would have had I not forgotten about an easy part. So we've got our slot for the bearing, a cross pin to hold that bearing, and the start of the hole that the ball comes through. The ball currently does not fit. We want that to come in from the back and ideally not fall out. What I need is like a bore somewhere in the top, I think, that this ball could actually drop in so then it could move forward and not fall out the front. As it is, I have no way to install this ball, so I'm going to take it back over to the As I was saying before I was so rudely interrupted, now comes the hard part, or the trickier part. I need to make a reverse sort of countersink from the back so I can drop this ball in. So I can drop this. I ran a deburr. There we go. I ran a deburr tool and I must have just made it worse. Ball drops in from the top and then it's got to move into a countersink, so just a little nubbin of this sticks out the front. Now I dug around, and these are my two smallest tools. This is from the Manila, but that doesn't have enough hook to really get back there and make the countersink I'm looking for. This one is a little scarier to use, but I should be able to open up the back. In addition to two tools, I have two safety nets. First, we could just bore this open so the ball fits in from the front and just let it fall out when it's not contacting the work. In use, this is pinched between this ball bearing and the work, so I think it should be usable. It would just be annoying. Option two would just be to drill in from the back. Like come in with a nice long drill and just stop just shy of the exit and let the tip of the drill leave that countersink that we need to hold the ball in place. Before we get to hyperventilating, let's try it with the small boring bar, see what happens. I don't know if you can tell, but that is a very small piece of carbide brazed on the end of that. I don't quite like how it's cutting. I'm going to drop it just a smidge and see if that sounds better. I'm really babying this thing. This is going to take forever. But again, I don't want that to break. And I should probably stop saying that out loud. That went a lot better. I'm kind of staying away from the front. I just want to rough out the clearance that ball needs before I start worrying about the countersink or whatever geometry that's going to end up being. Okay, I'm just going to keep at it and bring you back when the part is that. Took some patience and a set of optimizers. It's hard to see what's going on in there. Of course, there's a burr on the inside now I can't get to. I I think I could bring that out just a little bit further. It's okay if I have some extra play, as long as that ball doesn't fall out. But if I don't move it out far enough, I'm going to jam up against the ball bearing in the back. Probably would be smart to take some measurements. I may be able to do this with the bearing itself. All right, I may have overdone it just a bit. There's maybe, I don't know, 15, 20 thou down there. Gap between the sphere and the ball bearing. I think that's good enough to try. Last thing, I think I'm just going to knock these corners off. Well, just what do we have here? I'll tell you what I've got. Probably the 5th time. We've got the tool holder, the roller bearing, and the hardened metal sphere. Goes in like that. Ball bearing drops in like that. Now we've got this little pin. Keep everything in place. Keep everything in place. His was sticking out a little bit more, but I don't know, maybe it's colder in my garage. The eagle-eyed among you may have noticed that there's nothing holding this pin in. I mean, to be honest, there's probably not a ton of force on this. Like while I'm using the tool, that'd be a problem, but we should probably find a way to retain this. We've got a lot of options. In the video, that looked like maybe a headed pin, and I don't know, it was on the other side, a push nut or a circlip or, I don't know, a spot of weld or something. Loctite might also do this, or frankly, just a 1/2-inch bolt through this thing. Nut on the other side. Wouldn't look super professional, but I bet it would work. I'm just looking to try this, and generally speaking, I tend to prefer low-risk, high-reward methods. Now, since this is a pretty close fit, I could just upset some material on this pin and turn it into a press fit. Now, you could do that on the lathe. I'm just gonna... Pardon me. Rough it up a bit with my teeth. What that's done is upset that material, I don't know, 5, 6, 7 thousandths. Enough to make this somewhat of an interference fit. See, it won't go in there anymore. The downside of this is that it's like a one-time interference fit. If I had to take this pin out for some reason to replace this bearing, I don't know. It might work one more time, but certainly not 2 more times. But with any luck, I'll never have to take this out of here again. You remember before, probably 5 minutes ago, when we were cutting the reverse chamfer to hold that ball in, and I said that was going to be tricky? Well, I lied. That was easy to do. I was just being modest. What's really going to be difficult is not getting a mirror finished right off the first pass of this lathe tool. Probably a little more stick out than I'd like, but I want some space to sort of see a before and after, turned and then burnished. This is hot rolled. Typically doesn't get a great surface finish. Tends to be a little gummy, but we'll see what happens. I've also set my feed rate just a little bit higher than normal. Again, I'm trying to get a roughish looking surface. Somewhere between rough and passable. All right, I can't believe I pulled that off. Having never used something like this before, I'm just going to treat it like knurling. So I'm going to drop the RPMs down. It's about 300. And I'm going to drop my feed rate down to, I don't know what that is. 1/4 of what we cut at. Now I just need to find some oil. I wonder if coolant would do it. Oh, would you have a look at that? I hope you can tell the difference. Surprisingly, I wasn't cranking down all that hard. Let's grab some measurements. This mic's only good to 1 thou, but I bet we can pick that up. 952, 952. That is the same dimension. 952. Can you read that? I mean, technically the 2 is rolling a little bit higher there. Probably only a few tenths difference. I'm going to crank down the pressure just a little bit more and see if we can get some of this hazing out. Well, that certainly made a difference. And if you can see that lip or that edge, like it rolled that corner off quite a bit. So the forces are significant. So after, what was that, 2 passes? A light pass took some of this hazing out. It looked like we dropped a couple of tenths. A very heavy pass, according to my digital mic, took off 55 millionths. Did I do that right? It's a little bit more than half a thousandths. Here's maybe a bit of a closer look. Hopefully you can make that out. I also tried this with like a light engine oil. This side was just the coolant. I mean, it has some lubrication, but probably not as good as the engine oil. Now, frankly, I don't know if I pressed a lot harder here. It's about the same shiny, but it looks more burnished, if that even makes sense. I also tried some cold rolled steel. Although that does look better, I'm not sure how much of a difference the actual cold rolled made. Maybe it was just a better combination of speeds for this diameter? I don't know. It's certainly doing something. So the results of this tool, I mean, they're obviously smoother, but other than counting the number of black eyes I got, I don't really have a way to measure roughness. I do have one of these comparators, these like surface roughness gauges. You kind of move them around and compare, maybe. If I were to take a guess, this maybe went from a 63, I don't know, to maybe a 32. Hard to say. Those numbers, surface roughness, are RA, average roughness. That's a measurement in micro inches, or I guess microns, depends who you ask. It's the average height of the ridges or like the scratches left behind by the manufacturing process. Taller scratches, rougher surface. Smaller scratches, smoother surface. Now, sometimes roughness doesn't matter, sometimes it does. Probably safe to say that the smoother you need a surface, the more expensive it'll be to make. Imagine this, for example, was going to fit into a plain bearing of some kind, like a lubricated bushing. Too rough, and it'll wear the bearing right out. Too smooth, and you might get weird rotations and poor lubrication. Like there's not a lot of surface feature for that lubrication to spin around on. So again, sometimes smoothness is important, sometimes there's a Goldilocks zone, and sometimes, like with this, it just doesn't matter. It does make it look prettier, I'll give you that. So I guess you could charge more if somehow you got into machining for the money. Now, a cool side effect of burnishing, I mean, I don't know how much we're really seeing it here, but when you cold work metal like this, you increase its hardness, surface hardness. This burnished side, in theory, should be harder than this not burnished side. So there's that. Long story short, I'm going to have to play with this thing a bit more, maybe talk it over with the wife, before I make any life-changing conclusions. I'm probably going to have to keep notes on how different metals and different diameters react to the kind of forces my little lathe is capable of. We saw a 5 to 6 tenths change on this side, but how repeatable do you think that is? How repeatable do you think that is? And of course, this thing is useless if you need to work into a corner, like if there was a shoulder here. You can only get so close. Though, now that I've tried this, I am wondering just how a regular roller bearing, just on a stick, would compete. Like, if I just put this bearing on there like that with a bolt through it, that's certainly a hardened race, and it could get closer into those shoulders. I don't know. Did I really need to go to all the trouble of making a ballpoint pen? Though it kind of was fun to build. For now, I'm leaning towards sticking with what I know. Anything close, and especially under a thousandth of an inch, I'll set it up on the grinder or send it out. But again, this was fun to try. I'll definitely keep this in my back pocket. But you know what I'll keep in my front pocket? Each and every single one of you. Thanks for watching.